Okay, so when I moved here 25 years ago, I placed this here when I moved in, and it's been sitting there ever since, so it's kind of been forgotten. I wanted to take it out to have a look at it and do a restoration on it. And if you look here, you get a little clue what this is. Designed and engineered by Harman Kardon Incorporated, Plainview, New York. This is a model A402, and it's a integrated amplifier. It's got your phono, auxiliary, tape inputs, two tape inputs, two phono inputs, two auxiliaries. It's got your preamp out and power amp in. It's quite a capable unit. Back in its day, it was quite a nice amplifier to own. So I've had it sit here for 25 years. I want to take it out, do a restoration on it. Let's have a good look at it. I haven't seen this in that long, so a quarter century. So let's have a look. Oh boy. I don't know if you can see, the light's pretty poor. Let's get it up on the bench and have a good look at it. So now I got it on the workbench, have a better look at it. It's got cobwebs on it. I had this stored on the floor, and I had a case of canned soda pop above it, and eventually over time the acid within the aluminum cans ate through the metal, and it leaked all of this soda pop all over top of this thing. That's why it's like this. This isn't just dust, this is pop and probably mold from all the sugars. So yeah, this is just a complete mess. It's going to need to be completely disassembled and cleaned. I hope the potentiometers aren't ruined, and I hope the switches aren't ruined, because I probably wouldn't be able to source new potentiometer switches. The last time I used it, it was working okay, great, both channels. I had one channel cutting in and out because I can't remember which one of these switches was they oxidize over time, and you know, they had the silver contacts in them oxidize, and then they stop making contact, and then you have to work the switch a few times and get the signal back. But overall, this is a very, very nice amplifier, designed in the 70s. You know, it's all discrete component, except for, I think, a few integrated circuits in the LED display. The beauty of these Harman Kardons in this era is that they design their equipment with a high bandwidth, so it's got you know, bandwidth that's over and above the competitors, and what the result is, you get a cleaner sound. And this is a very nice sounding amplifier. I'm going to get it back and running. So I'm going to have to do a severe clean on it. I'm going to have to go through, I don't know what's leaked inside. We'll take the cover off here a second and have a look. I'm going to need to recap this because it is pushing 40 years old now, and we'll just work it from there, and we'll get it back to life. Let's take the cover off. So I got the screws off. Let's just have yeah, everything's stuck together. Okay. First impressions. Doesn't seem to be as bad as I thought it would be. It looks like the cover protected a lot of the chassis, except for the back here. There's some stains here. We'll have to clean this all up. Looks like the boards are just bare copper and don't have any solder mask, which, you know, might see some corrosion here. Let me see if I can tip this up. Get a better look at it. Okay, so tone control and preamps. This board here and this board here. I think no, this is the preamp, I believe, for the phono. Some switching. This is a massive heatsink. This amplifier is rated 40 watts per channel, and one of the selling features of this amplifier back in the day was that it had independent power supplies for left and right channels. The thought was that it helped with dynamic response. I'm not sure about that, but we'll see. Anyways, caps, we're going to have to replace these. These are 4700 microfarad 50 volts. I'll see if I can find those. They're probably okay, but I think I might just replace them regardless. I can see I was in here probably many years ago and I replaced a few caps on the power amplifier board, but we're going to go through and recap this thing all from start to finish. We're going to clean the chassis, get everything back to 100% working. So yeah, it's a nice unit. Here's some display drivers. There's two boards there. Interconnects, switches. Interconnects are going to be suspect too. These things oxidize over time, and you get your poor connections, so scratchy sound. So we're going to go through this. Alright, let's take the bottom panel off and have a look. Alright. The bottom panel. And everything looks good. Looks nice and clean in here. Looks like the liquid didn't get to the bottom workings of this. Everything looks dry. There's no stains. There's no stains on the bottom plate. It's just good news. So maybe the damage is mostly cosmetic. We'll have to clean it up and see how bad those switches are. I noticed a few of them were sticking a bit, but that might be just the front panel, the front bezel. Okay, so what I'll do is I'll order up some caps. I have the service manual for it. It was easily downloaded, and it has all the part lists in there, so I'll go through the part list and I'll tally up all the capacitors I need and put an order in, get some fresh caps in this thing. I'll go through and I'll check, there's a regulator here, regulator board, check all this out, check the resistors. Yeah, clean off this, all this crap, this dust. Go through, we'll do the power amplifier, and we'll recap that, and realign everything, and get this puppy working again. Okay, so I'm finding online that I can order these switches. It seems like I can. They seem like a pretty common stock item. So I'm going to take the two PCBs out that relate to that switching function. See if I can figure out what kind of switches. I've just got the screws out of the top and the bottom of the aluminum extrusion. Let's pull these knobs off. Oh my god. It's on there tight. So I'll put these in the ultrasonic cleaner and get them cleaned up. And take this off. You'll see the front panel under the schmeg. So I'll take this apart, pull these boards out, and then I'll see what I can do for switches. I got one here too. Speaker switches, I can order those as well. I think I'll order all new switches if I can find them. Might spend me all day on the websites looking for them, but I'll see if I can hunt these up. All right. Okay, so this is how I deal with boards that have liquid spilled on them, especially water-soluble liquids like coffee, pop, anything like that. something that water is your main solvent is going to dissolve. So I'll just put it under the water, usually hot water. And I got a little brush, and I just go in and clean it up. Take a look. Oh, it's still dirty. Just try to get the brush in between the components. You won't get 100%, but you'll get probably 95% of it. And you want to get all of that spilled liquid out because it will be conductive. And you'll get current leakage throughout the board if there's coatings on it that are conductive with anything that's syrupy or acidic. So just give it a good look. I think I still have a little bit here in the corners. Give it some more. I also heard that you could put these boards in a dishwasher and run the cycle, but I've never tried it. Now obviously underneath these caps you're still going to find traces of the spill, but I'm going to be replacing these caps, so I don't care about them right now. When I pull the caps off, I'll check underneath, and if there's anything there I'll clean it as I go. Basically what you want to do is make sure that the resistors and transistors and capacitors don't have anything around their leads. And I think I got it. There's still some. There's still a little bit left around this one transistor. Just want to get right in there. The brush helps a lot because the water won't flow all the debris away. Okay, that's the first step. Okay, the second step to this is drying the board. You don't want to leave it sit wet for any amount of time. You want to dry it off as soon as you wash it. Best way I do it is I use my hot air gun, and I set the temperature relatively low, probably about 350 degrees Celsius. I don't want to burn anything here. I just want to heat it, turn up the fan to max, and I just go through and I heat the board up, all the components, drive off all that water. Give it a thorough heating, just to make sure that you get all the water that's under the capacitors and resistors. I don't want to overheat anything, I don't want to burn anything, otherwise I'm changing more components than I need to. Like I said, all the electrolytics on this board will be changed, so I don't care if I heat them up. But generally you don't want to be heating electrolytic caps with a hot air soldering rework station because they'll explode on you. So I'll just gently heat this and drive off all the water. I'm still seeing. And you know what, if you see that there's still, under the resistors and transistors, there's still some stuff that needs to be washed out, do a second wash on it. The back side is pretty much dry now. Yeah, it is dry now. And I think I have everything out the front top. Okay, good. Now this board's ready for cap replacement. Okay, so I had to disassemble the chassis just to clean a few things. This board here was parked right here. Actually it goes like this, sorry. And it had a big gob of sticky mess on there, so I had to remove this board, clean it up. I'm pretty sure I got it all now. Looks good. And then it gave me a chance to lubricate these switches. These are all open wafer switches, so where's my cleaner? So just give it a shot and then work it back and forth. So, and then you get in here and lubricate the ball bearing detent and the shaft, just to give it a better feel, clean it up. And then I'll work on cleaning up the chassis. I still have a mess back here. Clean this up, and I'll have to check all of these connections on the phono inputs and outputs. So you make sure there's no cracked, stressed solder joints, and make sure everything's good there. And I'm still waiting for the caps to come. They should be here today. So I'll just put these boards aside. What I did is I ordered the switches as well. I think I'll put some new switches on these. These 45-year-old switches are pretty oxidized. So I'll just keep plugging away, cleaning until the parts get here, and then I'll start replacing caps. Okay, just a little update on how things are coming along here. I got my parts in yesterday, and I just wanted to go over a few things. For example, electrolytic capacitors. One thing you got to pay attention to is the physical size of the capacitor. These old capacitors are 45 some years old now, but the technology's come a long ways. So 220 microfarad capacitor, look at the difference in size. So that's one thing you have to consider when you're replacing caps. The main power supply electrolytics, these ELNAs, these are actually good capacitors, 76 date code on them. But I opted to replace them anyways, and this is a 4700 microfarad, yeah. And what I did is I got one that's the same physical diameter, 30 millimeters, but what I did is I upped it to 10,000 microfarads, and I bought brand capacitors. I bought them all same brand just to keep it uniform, but upping the capacitance from 4700 to 10,000 shouldn't pose any problems in this kind of power supply. The only problem I might have is it might pop a fuse, because you know, the difference between charging up this, when you switch it on from a cold start and you have to charge up this capacitor compared to this capacitor, it requires, you know, twice the energy or 4 times the energy. I don't know how you do the calculations, but the slow blow fuses in this should hold up. If it doesn't, I'll have to think of something else, but that should be okay. Also, yesterday I took the time and I was removing switches. I had to desolder these boards. I'll clean them all up. But I want to replace these switches because over time they get very scratchy. And I have a theory why that happens. People say, well, they're dirty, spray some junk in there and clean them out. No, well, it's not really like that. The construction of these switches is, you got a base metal, and then it's plated with a thin plating of silver, and the silver is there to do you know, improve conductance. But the problem with silver plating on these switch contacts is that after 10-15 years it oxidizes, and you lose your continuity, and you get a scratchy signal going through it. These are all signal switches. There's really no current going through them. There's just a voltage, a small voltage at that. So yeah, I'm not big on these switches, the original ones. So what I did is I opted to, where is it now? I can't find it. Give me a second. Hold off. Parts spewed everywhere here. What I did is I found these. These are gold plated. Now, if you read the spec sheet on these switches, you'll see that they're only good for 40 or 50 milliamps at 50 volts. That's what their spec is, which is fine for audio work, audio signal switching. You can't use these for switching current. If you want to switch current, you have to go to a silver plated switch. So I'm going to replace the switches with these gold plated ones, the silver plated ones with these gold ones, and I'm going to hopefully this will improve the the function of the machine. I couldn't get these dual pole double throw switches in gold. They were on back order, so I had to just order this silver. So I'll go with these for that. And for the speaker output, I opted for the silver plated because they handle a higher current, and I wouldn't put a gold plated switch in that application. So I got some busy work here. I got to take these switches out of this rail and replace them, and they should just drop right in, the same dimensions and everything. We'll get that underway. I'll get started on that, and then we'll get this thing back together, start recapping. I'm just going to show you how I replace these switches. It's pretty simple. Actually, the hard part is desoldering all these pins from the board. And one got bent there. How come? I guess, okay. So it's pretty simple. To get them off the rail, you just lift these tabs up, straighten them out. You just want to get them straight so that the switch slides off. This is all that's holding the switch in place. A pair of needle nose will work for this too, but this is a little sharper. Okay, all you really need to do is just pry them up and out. And remember your orientation, obviously. What did I just do with that last switch? Here. Okay. And you know what? If it doesn't fit, straighten the pins some more. It should just slip right on. There we go. Yeah, get them orientated the right way helps. So you want all your pins facing down and all your lugs facing up. And then it's just a matter of crimping these back in, and then they'll stay. Make sure they're seated fully. Okay, now that's ready to be soldered back onto the PCB. I don't know if I can get this into the field of view. No, I'm going to have to move my camera. Just bear with me. So this is the printed circuit for this switch assembly, and I cleaned it a little bit, cleaned the flux, and it just drops right in. And I can tack that in and solder that in. Try not to move these cards around too much, these boards, because the whole amplifier is hand wired, and you start breaking connections. So I try not to move it, or move it as little as possible, just so that those wires don't break off. So I was going through and changing caps on these boards. This is the preamplifier board. It's got the bass, treble, tone controls, and look in here, look at this capacitor here. It's got juice leaking out of it, and that is not a good sign, and that's the reason why we go through and change all these caps on these boards, is because eventually they're going to start leaking. This one's hung upside down actually in the chassis, so you don't see that just from taking the cover off. You pretty much have to disassemble everything to see this. So yeah, this is why we recap vintage audio equipment. Just to show you one of the hiccups I run into, I soldered this board on the top of the switches, this top board for the and I ran into a problem where I soldered it all together, put it back together, and one of these switches wouldn't work. I was like, what? I got a defective switch, so I had to take it all apart. What I found out is these switches, the new switches I replaced, are actually, they sit, let's see, the top pins on these sit probably a millimeter or two lower than the original switch. So this board is actually a millimeter or two closer to the switches than it was intended to be. So that's what was the problem. The board was hitting the mechanism for the latch on the switch. And what I had to do is take a Dremel and carve out probably about a millimeter or more. And then I had this big fat capacitor down here that was hitting the board too, so I took some of the board away for that. And now the top board fits really well, and doesn't interfere with the function of the switch. So I'll solder that back together. That's one of the little things I ran into. So I got the unit assembled, with the exception of the power amplifier module or board. I have everything back together. Everything's recapped. What else to tell you about this? Oh, all new switches. Okay, so I have it here plugged in, and I'm going to power it up for the first time. Here we go. Pretty quiet, and no popping of fuses. So we're just going to check the voltage rails on, where are we here? The B plus, B minus for the power amplifiers is plus minus 37.7 volts. We also have a B3 line. B3 is a plus 575 volts. B4 is plus minus 20.4. B5 is 18.5 volts plus minus, and B6 is plus minus 11.69. So we got quite a few different voltages in this amplifier. I'm going to check a few of them here. Let's start with the negative on chassis ground. Let's get a voltmeter in view here so we can see what we're doing. Oh boy, I got a big knot here. Okay, so we got a negative on the chassis. .40 minus 41.5 plus 41.5 minus 41.1. Everything's working good with that. Let's flip it over and check the B3 supply. This thing's powered up. Have to remember not to touch anything. Short anything out. Okay. Can't see that there. Here we go. .5, which is what it's supposed to be. Okay. These two wires here, this brown and this red, you can't see it. Let me change the camera. These two wires, this brown and this red, feeds up here, goes down, and it goes into this board here, which is the display unit. And I'm just going to measure. Yeah, we still have plus minus 41 volts on this. So right here is a little regulator for it, a couple capacitors, a couple Zehners, and that will supply one of the voltages for the op amps on those boards. One more thing to do before I shut this off. So I'm going to test the display function. It's all working. Alright, looking good. Have a one yellow there's pretty dim. I don't know how not that noticeable. Probably a weak LED. Here we got the power amplifier module. It's a massive heatsink. Printed circuit board. I'm taking the screws out so we can just lift off. We can just lift off the transistors with the heatsink, all as one unit. Just like that. Okay, I'll put this aside. I'll clean this up. I'll get rid of all of the excess heatsink compound, and I'll clean this all up and get it ready for reinstallation. But right now, let's take a look at this and see if we can find anything going on here. It all looks pretty solid. I don't see any cold solder joints. These connectors here will take some stress as the amplifiers heats up and cools down. They'll take these will have stress cracks, but these look like they've been resoldered. I probably resoldered them not too long ago. Okay, so let's get on to recapping this. We got 1, 2, 3, 4, 5, 6 caps. All right. I'm going to try and do this with a camera in front of me. You know what? I'm going to... Now, did I miss that? I got the wrong one. Maybe it's this one. What did I desolder? A resistor, I guess. 1000 microfarad. I love these boards. If you look, you can see everything's printed out on there. You got C408, it's 1000 microfarad at 10 volt. You got the resistors, and they all have their value next to them. So if you ever burn out a resistor, you can always go and read the board and change it and get it back running again without searching for a manual. Okay, disorientated the right way around. Just leave that there for now. I'll solder them all later. These Zelda caps are quality caps. It's just I'm going to go through and test a lot of them and see just how they fared up over the last 45 years. I'm not saying they're bad caps, but they're probably getting to that point where they're getting aged. Okay. Come on. There we go. It's a 10 microfarad. I don't know why they put tape on them like that. Okay. I'll solder up these three. Come on. Excellent. Okay, one channel's done. Let's do the other side. Next one. And the last one I don't think I can get. Let's get this from underneath. If that socket wasn't in the way, I could use my solder sucker. Okay, 1000 microfarad. 100 microfarad. And 10 microfarad. Okay. I'll go through and clean up the rosin flux, and I'll go through with a multimeter and I'll check all of these resistors for value. I don't expect to find any of them out of tolerance, but I usually just check them just for course of what I do, and if I do find any that are out of tolerance, I replace them. Resistors are so cheap, it's just not worth leaving in an out of tolerance resistor and then risk having a meltdown in your amplifier in the future. So I go and do that. So I'll get my multimeter out and start checking these resistors, and then I'll clean up the board and then reassemble. Alright. So I went through with an ohm meter and checked all the resistors in both channels of the power amplifier, and I found one resistor in particular that was out 470 ohms, and it reads 542. So considering it's a 5% resistor, it's out by 18%, so I changed those two resistors, and hopefully that'll make things better for this amp. Okay, I went through and cleaned up all the back of the board. I took off all the rosin flux with the cleaner, and I cleaned up all of the old heatsink compound, and took a look at the mica washers, and they all look good, so I'm going to use them again. Just putting everything back together now. Tighten these transistors down. Okay, now one thing I always do when I change any transistors with insulated mounting hardware, I always check continuity between the heatsink and the device itself, just to make sure it's not shorted. Everything's good. Okay, so this is ready to go back in. Ready to go back in and for alignment. So I'll spare you the boredom of me bolting this back in the chassis, and then we'll get down to setting this up. Okay, so we got the amplifier back in the chassis, and it's all connected up, bolted down. And we're going to move on to this power amplifier idling adjustment, and it calls for a vacuum tube voltmeter, which I don't have, but I think my DVM will work. It's got high enough impedance. So before we do this adjustment, we have to set this unit up. So function selector set to auxiliary position, which I did. Volume control to set to minimum, and tone balance control to mid position, so everything's set that way. Set mode control switch to off position. Set the speaker switch to the on. Yes, I got that on. Set display control switch to the off position. I have that turned off, and then I have connected an 8 ohm 50 watt resistor across left and right speaker terminals. Okay, so I have my 4 ohm 100 watts. I got 2 of them in series, so that's my 8 ohms, and I got 200 watts of dissipation, so I got no problem there. Okay, so the procedure is just put a voltmeter across this resistor for one channel, and then adjust VR 401 for 15 millivolts, and then we do the same thing for the other channel, and it even gives you a little diagram of where these resistors are. 435. Okay, so let's do this. I'm wondering how I'm going to get the voltmeter in the screen here. It's not quite tall enough. I'll move my... Okay, we got our probes. Turn the amp on. Oh, we got to plug it in first. Okay, turning it on. Lights went dim in the house, so we're good. I don't know if you can see that. Hope you can. So first one is 435. 435 is, let's see, this drawing is backwards, upside down. 435 is this one. So let's see what we got across this resistor. Are we there yet? This is not easy with... No, I'm not there. I'm not connected. There we go. So we got 8 millivolts. Let's adjust this to 15. Pretty finicky. I got it up to 14 pretty good. Maybe the track is dirty. There we go, 15. So in case you're wondering, 15 millivolts across a half ohm resistor, 0.47 is about 32 milliamps of idling current. That's what we're setting it for. Okay, next one is our 436. 436 should be this one. No, you know what? I think I did that wrong. 436. No, that's right. 436 is this one. See if I can get in there with my probe. What do we got? 0.4. Let's crank that up to... Something's wrong here. I can only get it up to 14. Or no, I can only get it up so high and then it drops to 0. 7, 8, 9, 10, 12. See, then it drops to 0. What is going on with this thing? Let me check something and then I'll be right back. Okay, I just wanted to check off camera that I was measuring the right resistor, and I am. But let's go through this again one more time. And it says the adjustment is plus or minus 5 millivolts, so it's not... I had it at 12 here, and that's within plus minus 5 millivolts. So let's check the other one again after I've done. This is hard to do with the camera in my face. Okay, let's see what we can do here. See, now it's at 18. Why did it jump up so high? Let's turn it down a bit. Let's turn this down a bit. Okay, we'll leave it there. Alignment's done. Let's do some performance testing. So I started the amplifier up and started doing some initial tests, and ran into a problem right away. I hooked up the right channel to a signal generator and the speaker, and the amplifier fired up fine, and then after maybe 10 seconds the right channel cut out, and I'm scratching my head and I says, what's going on here? And I know the amplifier has a soft start feature, and so I start looking into that, and you know, I got the schematics here. Soft start is up here with the power supply. It taps off the main supply, and then there's a RC delay, and it switches the transistor on. And with 3 seconds or something after the power up, I don't know if it drops this line to ground, or I think it drops this line to ground, and then it goes into the amplifier itself. So I thought maybe this was wrong, something wrong with the soft start, like it was maybe tripping, sensing something. But then it can't, because it's only a one-way path here, because there's protection diodes down on the bottom of where it enters the circuit. So I checked the left channel. The left channel is working fine, so something was isolated with the right channel. I get my voltmeter out and I start going through and checking all the voltages on the transistors, and they were all normal and they all matched right and left, so something's not quite right here. And then I got my stick out and started poking around. Oh, actually, sorry, what I did first is I got my oscilloscope and I started tracing the signal, and there's a signal in the left channel, no problem. The right channel had nothing. Got my stick out and started poking around, and then as soon as I hit this capacitor, the right channel kicked back on. So, oops. And I don't know if you can see this. I pulled let's see if we can get some light on this so you can see it. So, even guys like me make mistakes on the soldering, and somehow I completely missed that capacitor I soldered in. It appears soldered, but my eyes are bad and I couldn't see that, so I'll fix that, and then we'll get on the way with testing this thing. Okay, so I'm running a test on the power amplifier. What I do is I feed it with a signal. I'm feeding it with 60 Hertz sine wave, and the signal generator is outputting half a volt. And I got the volume turned right up until I see clipping on the oscilloscope. I don't know if you can see this. You probably can't see my scope with this glare, but it's outputting a signal of what does it say? 28.4 volts peak. 28 volts peak is, let's see, let's do the quick calculation. 28.4, 707 equals 20 volts RMS. So what I'm doing is I'm just checking the amplifier for this is getting warm. I'm just doing one channel at a time here. This side's staying cool. But what I do is I check the transistors to make sure that none of them get hot, which would tell me that they're not heat sinked properly. And I check all of these components just to make sure nothing's overheating. The emitter resistors are hot. Well, actually they're collector resistors. And the output resistors, I have two. I can't even touch these, they're so hot. So the amplifier is performing good on this channel. I'll usually let this cook for a while, and just to make sure that everything's functioning the way it should, and I'll check the other channel. But the specification is 40 watts per channel. If I do the math on 20 volts RMS divided by 8 ohm load, I should get 2.5 amps times 20 equals. So I'm actually putting out 50 watts. The amplifier is rated for 40, but I'm putting out 50 watts before it starts clipping. That's at 60 hertz. We can check it at different frequencies if we have to, but really no point. It's quite an impressive amplifier for its age. It's got a power band with 10 hertz to 60 kilohertz with less than 0.1% total harmonic distortion. Both channels driven simultaneously into 8 ohms at 20 watts per channel. I'm not going to test any of this. I can test bandwidth easily enough. Frequency response is plus minus 3 dB, 4 hertz to 160 kilohertz, which is pretty impressive. Most gear from that era was usually 20 to 20, if that. Yeah, it's a nice amplifier. Alright, well, I'll test the other channel and get this thing wrapped up. So I went through and checked all the caps with this tester. This is just the capacitance and ESR. I have it set up for ESR. Didn't find any obviously bad caps, but I did notice that they are aging quite a bit because the ESR is creeping up there. All the filter capacitors, these ones here, these are in power filtering circuits. They tested fine. A lot of these smaller ones are, these 220 microfarad ones. These are in the plus minus regulated supplies, so they're fine. A lot of the smaller ones, the ESR creeped up. Was starting to creep up. For example, this one here I think was leaking. But it still tests 22 microfarad, which is what it is. It's got a 2.5 ohm ESR, which is, yeah, it's not great. If I pulled out a brand new cap, that ESR would be a lot lower. So yeah, these are definitely on their way out. They're 45 years old or more, or not, just about 45 years old. So straight into the garbage they go. Ouch. And got all brand new caps in there now. Okay, so that wraps up this restoration of this, in my opinion, a beautiful amplifier. The A402 Harman Kardon. This amplifier I'll probably put on in my maybe in my living room and use it. It's too nice to just have it sit and collect dust. I love the design of these the brushed aluminum, polished. It's not even polished, it's just brushed. I got that bad. Yeah, so it's a nice unit. It gives a great sound. Simple design, and it's nice. I like it. So all new caps, upgraded the power supply electrolytics, the filter caps from 4700 microfarad to 10,000, and it performs very nicely with that. Replaced all 11 signal switches with brand new, just to keep it from causing any problems the next couple decades. And yeah, it's a beautiful sounding machine. I'll have to set this up and use it. Alright, well, thanks for watching. Hope you got something valuable out of that. Let's just hope that we can keep these nice pieces of engineering going for a long time. Alright, thanks.